Okay, so we're going to be solving logarithmic and exponential equations. There are basically three types of equations. The first type is when you have all log terms, and when you have all log terms, you want to get it into this form, log base m, log base b of m equals log base b of n. That way you can just get rid of the logs and just put m equals n. All right. On b, when you have no log terms, what you're going to end up doing is you're going to isolate where the variable is, and then you're going to take the log of both sides. For instance, you do uh, log of 2 to the x equals log of 5, and what happens is that x gets to move to the front, so you have x times log of 2 equals log of 5, and then you solve for x. The other one is a combination, which you've already been practicing on. Here, this is an addition, so that would be log base 3 of 5x equals 2, and then you would do I heart logs in order to get 5x is equal to 3 squared. And now, since you change it from logs to exponential, you'll be able to solve for x. And we're going to practice that here right now. All right, the first problem I want to go over is 2 times log base 2 of x plus log base 2 of 5 equals 8. Now notice that's 2 times this. And actually the first thing I can do is I can get rid of that 2 because it's times 2. So what I end up with is log base 2 of x plus log base 2 of 5 equals 4. Now with this, remember your law of logs, I can multiply that. So I end up with log base 2 of 5x equals 4. Now that I'm at this point, I have one log on one side. Therefore, I can do change this to an exponential. Remember, I heart logs. So this would be 2 to the 4th power equals 5x. And in doing so, now this is 16 equals 5x. And when I divide by 5, x is equal to 16/5. And then I can plug that back in place right here and see if it would and put this in the calculator and see if it equals 8, and it does. All right. The next kind of problem that we can do is when you have no logs at all. So 3 times 5 to the x power plus 5 equals 17. Now notice we want to isolate that right there. So in doing so, we're going to subtract the 5 first, and we're going to get 3 times 5 to the x equals 12. Then we're going to divide by 3, and I get 5 to the power of x equals 4. Now notice there's no logs. And how do you get this x out of the power? Well, if you take the log of both sides, if we do the log of 5 to the x equals the log of 4, well then what happens is now I can actually move that power to the front. And I get x times log base 10 of 5 equals log base 10 of 4. And if you come back up here, I can solve for x by simply just dividing both sides by log 5. And that gives me my x value by itself. So x equals log 4, log 5. Now you can put this in the calculator, log divided by log, or you can put it in the calculator as log base 5 of 4. That's when we did our change of base. So either one of these ways would give us the same answer. Okay? The next scenario is when you have a combination. 3 log of 2 plus log of x equals log of 24. Well, in this case, I'm going to bring that 3 here. I get log of 2 to the 3rd plus log of x equals log of 24. 2 to the 3rd power is 8, so I end up with log base 10 of 8 plus log base 10 of x equals log base 10 of 24. Now, because this is addition, I'm going to multiply 8 times x, so log base 10 of 8x equals log base 10 of 24. And because these two logs are the same, I can simply write 8x equals 24, divide by 8, and I get x equals 3. And then the last one that we're going to do is a little combination on both sides. Log base 2 of 3 plus log base 2 of x equals 2 times log base 2 of 12, log base 2 of 12 minus log base 2 of 4 plus log base 2 of 3. Now, this left side is going to be easy because this is simply a multiplication. So this is log base 2 of 3x. Now I'm going to leave this 2 here, but I want you to notice which one comes first. Well, you have a subtraction and you have an addition. Well, in this case, we want to do this one first. So what you end up getting is log base 2 of 12 divided by 4 plus log base 2 of 3. And we're going to do it step by step. So this remains the same. Bring down that 2. 12 divided by 3 is 3. So log base 2 of 3 plus log base 2 of 3. Well, as you notice, 3 times 3 is going to be 9. So I get log base 2 of 3x equals 2 times log base 2 of 9. I'm going to take that 2, bring it as a power. So log base 2 of 3x equals log base 2 of, now 9 to the second power is going to be 81. And now that I have the logs equal to each other, I get 3x equals 81. And what I end up getting is 3x equals 81 when I divide by 3. X is equal to 27. So now you have some different ideas and ways that you can actually finish that.